The phase leg can be understood again by considering a circle where I am considering a particle is having the circular motion and I am interested to see its projection. So this is my vertical plane and this is my object which is exhibiting a circular motion, and let this is object number 1. If I will make the diagram of the displacement with respect to time, I can write a simple sine wave here. And in this sine wave, this time gap is actually representing the time period of my system, and this maximum value is representing the amplitude of my motion. At given instant of time, suppose particle reaches to this value. So in this curve, the position of the particle will be somewhere here. Now at the same time, I am assuming another particle which is also exhibiting the similar motion, but it is starting its motion from this position, and both the particles or both the objects are having the equivalent or equal angular velocity. So when this particle will reach to the position theta value, it will also reach to the theta value, but from its initial position theta, and initially both the particle was having a gap of 90 degree. So if I will make the diagram of the second particle, that is going to be start from this point because it is already starting motion from this point. So this will be in this way. So now what I want to convey, I want to visualize you to understand the difference between the velocity and the displacement, because the velocity curve look like the green curve and the displacement curve look like with the red curve. So this is actually representing displacement of the simple harmonic motion when I am representing my motion with the sine omega t, and the green curve is representing the motion of velocity, that will be x naught omega x dot is equal to x naught omega cos omega t. If I am interested to see in the physical world that how the particles are moving and how I will define the difference in phases, so we can say that the phase difference between particle 1 and 2 is 90 degree every time, because whenever the first particle is move to the a particular position, the second particle will always ahead by a 90 degree rotation in my circular motion. So if I will correlate this circular motion with this wave or with this graph, I will be able to understand that if I will extend this curve to back, this is actually, if I am assuming both the particles are rotating continuously. So when the particle 2 would have been here, the particle 1 would have been here. When the particle 2 will reach here, the first particle will reach here. That means both the particle will always have a 90 degree gap. And generally, if I am writing first with x is equal to x naught sine omega t and x dot is equal to x naught omega, I can convert this function in the sine term. I can write sine pi by 2 plus theta for a given instant of time, or omega t. So you can see here that this is the phase leg, but here we can see that the velocity. Here I want to give you one statement that whenever you are looking the curve in this fashion, please try to produce the curve backward, and then we can say that the green curve is actually 90 degree ahead of the red curve. That we can visualize from this diagram. So velocity is actually leading by 90 degree and leading to the displacement. Similarly, if I am making the curve for the velocity as well as the acceleration. So let's try to understand the phase leg by just looking this curve. So this is the first curve of your displacement, and the second curve I am making for the acceleration. So from the acceleration, we know that x double dot is equal to minus omega x square. So the magnitude will not be same, as well as it is having a negative sign, or if I will convert it, then minus omega square sine omega t x naught is also here. What I can write here, I can write omega square x naught sine pi plus omega t. So you can see here that this negative sign is now gone, because I have written here that the pi plus omega t, it is indicating that the acceleration is actually pi ahead than the displacement, and that can be represented by this curve, that this is the actually curve of acceleration which is starting from the negative side. But if you want to see which curve is leading and which curve is lagging, what you need to do, you have to make all the curves starting from this similar fashion. So actually, if you will create a backward curve of acceleration, you will find that the acceleration is actually starting from this point. That means the acceleration is pi radians ahead from the displacement. From the mathematical expression, you can understand that I am changing the sign with the sign pi by omega t. When you are looking this curve, you will be able to understand that it is actually starting 90-degree ahead. If I will add the velocity curve, actually the velocity curve is starting from here and it is moving in this way. All the three curves are having same time period. Please don't get confused. The three curve will have the same time period, but amplitude will be different, as well as their position of starting the curve will be different. And if I am looking from this point on ahead, I'm not looking this portion, so what I will visualize, one curve is starting from here and it can be considered as a displacement. The second curve, let's starting from here. So this would be your velocity when you are talking about the simple harmonic motion, and next curve will start from a third position, that would be here. Plus, please understand, all the three curves are having same omega but different initial position, and that is actually indicating the lagging or leading condition. Now, the third and very important thing, that actually what is there in the physical world. So this can be understand that when the displacement is having its maximum value, the velocity is having zero value, and the acceleration is also having maximum value, but the in the opposite sense. So when we are talking about particle at the mean position or the projection at the mean position, we are referring this position in my curve, which is time versus amplitude, and amplitude of displacement, velocity, and acceleration. When I'm here, displacement is zero, but velocity is maximum in positive sense. So this is the positive direction. So this is having a positive value. So V is maximum here. When I'm reaching here, that means I'm reaching at this point. So at this point, 90-degree position it is here, because the complete path can be divided by 90, 90, 90, and 90. So the complete will be 360-degree. So I am here now. This is my position 2. So on the curve, it is my position 2. At position 2, displacement is maximum. Yes, x is as maximum value, but velocity is 0. Yeah, definitely. When the particle is again changing its path or turning back, so the velocity will definitely be 0 at this point. What about the acceleration? The acceleration, when I am here, the acceleration value is 0. When I am reaching here, the acceleration value is maximum, but in the opposite sense. So in this way, we can visualize a simple harmonic motion. We can also visualize the phase of the motion, as well as we can also see that how we represent a simple harmonic motion in mathematical term, as well as by considering time versus amplitude plot. And here I have demonstrate that three different lines are representing three different properties along with different phase position. So with this note, I am closing the simple harmonic motion. Now we will talk about the simple harmonic motion as a motion of pendulum and as a motion of simple spring mass system.